Hello students, welcome back. So in this session, I'm going to show you in Pandas how you can read the data files the right way. So the data files that we'll be talking about were the files that are really huge. Okay, so they can make an impact on your performance. All right, so let's import our necessary library. So this is the library that I'll be using. So come over here, paste it, and run this cell, and there you go. All right. So first thing is let's generate some data. I'll be generating some data and I'm going to be exporting the data into a CSV file. Okay, so let's generate some fake data for testing. And then I'm generating approximately 1 million rows. All right, and this is my data right here. Okay, so what it means is that there is a column ID, there's a column name, there's a column age, and so on and so forth. So let me just show you what this means right here. This is saying that generate me a column. Okay, generate me a data for the column amount. Okay, and then the value should be between 50 and 500. Okay, and how many I want size equal to n, which is right here 1 million. This right here, it is saying that generate me names, and the names should be only from this list right here, and I want approximately actually 1 million rows of names from here. All right, so I converted my data, my dictionary into data, okay, data frame, and then I save that to a CSV file, and then I run this. So it takes approximately like 3 to 4 seconds for this file to get created. And as you can see, the data file is successfully created. Okay, now let's look at some of the few values. I want to see how my data looks like. All right. So let's look at some few values and you see ID, name, age, amount, status, it printed everything. And you can see some of the values right here. Okay, these are some of the sample values. Okay, now let's use data type to specify column type. Let's see how we can use data type to specify column type and how exactly it improves our memory. Now, anytime when Pandas tries to read a CSV file, is guessing. It's guessing when it's reading a column, data from the column, like what type of data that is in the column. It guesses, and generally when it guesses, it makes a very bad guess. So let me show you through an example. So same file now, I'm going to try to read. So this time I'm not specifying any data types. I'm basically what I'm doing. I'm starting my initialize my process right here. Okay, it actually has a start time, it has an end time, and then right here I'm reading my CSV file. I read my CSV file, then I note my end time, and then I print few records. Okay, I print few records, and then I also check how much time it took. Okay, so I just do end minus start. End is your what time the process ended, and start is the what time your process started. And then I print my df.info memory usage. So as you can see, it took me approximately 0.203125 seconds, and its memory usage is 142.8 megabyte. And also it tells you for the column ID is int64. For the column name is object, for age is int64, for amount is float64, and so on and so forth. So it's basically telling you that this is the data type that Pandas assigned it, okay, for each one of the columns. Okay, so here Pandas assigned it on its own. We did not ask Panda to assign it. Now let's do that. Let's actually specify the data type explicitly using dtype argument. So I'm specifying my D type right here. I'm saying that hey, for the ID column, I want you to use int32. For my name category, for my name, use category. For age, use u integer 8. U stands for unsigned integer 8. For amount, use float32. For status, use category. Now, by the way, if a name is being repeated many times, then use category. Otherwise, use string. Just thought you should know. And age is a good idea that you want to use your age to be uint8. And the reason is because I know my numbers are going to be in the range from 0 to 120. So anytime when you know your numbers are going to be, let's say, from 0 to 255, all right, 255, oh, sorry, 255, then use uint, okay? All right, so let's run this. And basically, it's the same thing as the top command, except now I'm just specifying my D type right here, okay? And as you can see, it took me approximately 0.3475, which is a little bit more time. All right, took me a little bit more time. All right, let's see how it does on the memory. Oh, look at that, 10.5 megabyte. And what was this memory? 142.8 megabyte. Big saving in memory. And also you can see that ID has been assigned to int32, name is now category, age is unsigned integer 8, amount is float 32, and so on and so forth. Now let's see how much memory did we save, like how much it helped us. So I did all this work just to show you how much memory was saved. And I'm taking my 143 minus 11. 11 is my this right here, okay? Just approximating the value. And 143 is my this value right here. Okay, again, I'm just rounding it off. So 143 minus 11 divided by 143, and when you run this, approximately 92. So you saved 92% of the space, okay, just by using, by explicitly mentioning and writing your own data type. All right, so the conclusion is this: the process slows down a little bit, but you save memory. All right, it is, you can see that the process did slow down a little bit, but you did save memory. Now let's try another technique. In this case, you only load the required column. You don't read all the columns. So here we're going to make use of the columns, use calls. All right, so let's start with this. Let me just create a few more cells. Okay, so read all columns. Let's try to read all the columns the hard way. Okay, and this is exactly same I just did a minute ago. All right, so it reads all the columns, takes this amount of time. Okay, it print out the time. Then I'm also printing out the memory usage, and as you can see, 142.8. All right, now let's say you know that you only need few columns. Let's say you only need age and amount. Okay, let's say you're working with so you're analyzing your data, or you're working on a project, and their project requires only these two columns. That's it. So in that case, you can specify a parameter called use calls. All right, and you can just say, hey, just only load these two columns. And I did that, and then I'm checking my memory usage. Again, I'm doing the same thing, checking my memory usage. And as you can see, your memory usage is 15.3 megabyte. This should not come as a surprise, because now we are not loading the whole data, we're only loading part of the data. All right, so let's see how much memory we saved. In this case, if you do the analysis again, the answer will come out to be, let's see, uh, the answer is 89%. So approximately 89% space is saved because you used only the required columns you want, age and amount. Okay, now let's deal with the sparse data. Sparse data are the most, these are the data where most values are same. Okay, everywhere, most of your values is going to be similar or same, and often they are zeros or not in numbers or nans. And only few of the values, only fraction of values, they are useful, or you can say are non-zero values. So that's your sparse data right here. All right. Now let's generate some sparse data. So come over here and let's just create few cells. All right, so let's generate some sparse data. Okay, so this is my number of rows. I'm using my sparsity. This is where my sparse data is being generated. I put this in a dictionary, and then I put the dictionary into a data frame, and then I save it to a data file. And then let's run this, and let's see it create this file right here. All right. Now let's try to take a look at the sparse data. Maybe I just want to see how exactly it looks like. So you can do that too. So come down here, copy and paste, and let's take a look at my sparse data. How does it look like? So well, let's print out the first 10 records first. I'm printing the first 10 records, and you can see, okay, some zero. These are my first few records. It seems like most of the values are zero, but let's verify that. All right, let me comment this one out, uncomment this one. What I'm doing, I just want to do the value count, and value count is going to tell me for my column commute distance. Okay, with the one I just created, commute distance is what actually holds the sparse data. So in this column, I want to do the value count. I want to know my each value and its unique number. All right, so you can tell zero. Okay, it makes its appearance 90,031 times. Number 6, it makes its appearance 1,147 times. 2, it makes its appearance 1,143 times, and so on and so forth. So this tells you the unique values and how many times right here. This one tells you how many times it appears, the unique values. Okay, now let's try to read this CSV file. All right. So let's read the CSV file the hard way. In this case, I'm not specifying any sparse data type. So let's read this, and it took me, let's see, it's consuming this commute distance. As you can see, it's consuming 800,000 bytes. All right. Okay, this is I am not specifying any data type. So this particular column, commute distance, as you just see, it's a sparse data. Okay, it's all the values basically are repeating. You have like zero. Look at that, how many zeros you got, then number of six you got, and so on and so forth. This is a sparse data type. Okay, now let's try to convert this same one to pandas sparse data type. All right, so df sparse, I first make a copy of that, and in that copy I'm changing my commute distance column. Okay, I'm changing it to sparse int right there, and then I'm trying to print my memory usage just to see what happened after this. And you can see my commute distance now is occupying 79,752 bytes. Initially it was occupying 800,000 bytes, but because I'm using sparse data type, it is occupying 79,752 times. Okay, how much saving? Let's find that out. Copy and paste, run this, and you can see approximately 90%. So there's approximately 90% saving in space. So now I'm going to talk about how do you deal with Boolean data types. Now, if you know that your columns are Boolean in nature and that the values are going to be Boolean, then it's a good idea to use your data type Boolean. So let me show you through an example. So let's generate some data first. Come over here. Let's generate some data. And let's run this cell, and this is going to generate some data for me. So it generated a file, and over here it has these are the columns. Okay, is working and is remote. Is working actually going to have two values, not working or working. I'm just generating some data randomly. This particular one is going to have two values, zeros and one, depending on whether the person is working remote or not. Okay, so let's look at some of the few records. I want to see what's inside this data frame. Copy and paste, run this, and there you go. So see, is working, these are my values right here. Okay, is remote, 0 0 0 1 0, these are the values. Okay, now let's load this file without specifying my data type, and let's see how exactly it fares. Okay, how it performs. So let's load the file. And as you can see, first I'm printing my memory stats. So as you can see that I'm not doing anything. I'm just loading the file. That's all I'm doing. Okay, I'm not specifying any data types. Then I'm printing my memory. So let's just let me comment this thing out. All right. So let's print my stats first. So as you can see, this is your int. Okay, your employee ID is int. Your is working is object. Is remote is int. All right. Then I'm also printing out your memory usage, and I'm also printing out the total. So if you run this, and you can see your memory usage right there. Okay, it's going to show you memory usage is 7, actually right there. It's memory usage right there, and you can see for each column, okay, how much memory is taking. So this is in bytes for each column. All right, and the total is this bytes. Okay, so it's even printing the total. This right here is going to print out the total, which is right here. This is my number of bytes it's taking. All right, now let's try to redo the same thing. This time we're going to explicitly mention our data types. So I'm saying that, hey, I want you to use this data type for these columns. So I want you to use category data type for is working. Okay, I want to use for this column, I want you to use Boolean. All right, so let's see how exactly it fares. So let's run this. And basically I'm printing my memory stats again, and this one right here, this one is going to print for each column. This is going to print the total. So as you can see, first I print my df info. You can see this has changed to category, and this is Boolean now. Before it was let's see, this was object, this was int. Now it's category and Boolean, and look at that, is working. Look at that, how much bytes is occupying, less now. And look at this one, way less. Let's see how way less. So I want to compare. I want to see, like, actually first, let's see a few of the records. I want to see first my records, like how my data frame looks like now. Has it changed? And no, it has not. Look at that. Everything looks exactly same. You see, look at my data. It looks exactly same. Okay, nothing has changed. And the good thing is, look at the space it has saved now. So the space usage has gone down. Well, how much? So let's find that out. I'm going to show you. This is my space usage. For column is working, it went from this number to this number. So basically I'm just calculating how much percentage I saved. So you can see for the column is working. So my column is working. If you go on top, where was my column is working? Okay, I read this thing. is working right there. So this is my usage for is working. All right. So copy this, come down, and is working right here. So copy and paste. And this is my final. What is my final right here? Is this right here. So copy and paste it over here. All right. And then copy this and paste it over here. Okay. And let's run this. For my column is working is a look at the 98%. All right. Great. So 98% saving. Now what about my column is remote? How's that doing? Well, let's see. My final value is this number right here. So I put my final number right there. What was my initial number? For is remote. So if you go on top, is remote was this number. So come down, and that number I just wrote over there minus this divided by this, and that's going to give me 87. So 87%, approximately 87%. Big saving. All right. Now this is an optional. So if you know, you can actually squeeze some more space if needed. So what you can do is, like, let's say you know that your column is working, okay? You know there are only two values. There's a working value and there's a not working value, right? Not working and working. So what you can do, you can actually map this into true and false. Okay, so what I'm doing, I'm mapping my working to true and not working to false. And I'm changing this to as type data to Boolean, okay? And let's run this again. So I map this thing and I check my stats again, all over again. And as you can see, now it's a Boolean. Okay, it is Boolean. All right, now let's see how much memory has it saved. Well, what was the before? Let's check. So you can see this one was before. Where is that? Right, there it is. So is working. It's 1,000,132. Okay, so it doesn't seem like it has saved a lot. So if you look over here, come down. Okay, let me just create new cells. So how much memory it has saved? Well, this is my final for is working, right? This is my final. And what was my initial? So is working. My initial memory usage for is working right there. So it was taking this amount of bytes. Okay, so come down and put that number over here and divide it by same thing, and that's going to give you the percentage, like how much percentage of memory have you saved. Well, not as significant, only 0.01%. They're not significant, but just thought you should know that you can save some. If you want to squeeze some more memory out, you can actually save some more memory like this.